Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the second part of the series in which I'm solving CSIR NET Physics uh, June-November 2020 paper solutions. Okay, so also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so the first lecture was already done, and but there was some issue when I was solving question number third in first lecture. That time because there was audio issue, and after that that was not audible, right? So what I'm going to do is I'm going to start with that third question. Okay, so that you will be able to understand those questions as well, right? Because third question and fifth third and fourth question, yeah, third and fourth question was not audible. Okay, so I'm going to solve those questions first. Okay, okay, so the question was, a heavy particle a heavy particle a heavy particle of rest mass m of rest mass m. When I was solving this question, there was audio issue, and after that the video was that lecture was not audible. Okay, so that's why I'm starting with this question. A heavy particle of rest mass a heavy particle of rest mass m, while while moving while moving along the while moving while moving along the positive z direction positive z direction decays into two identical light particles two identical light particles with rest mass with rest mass m, where where m equal to that capital M. Okay, capital M equal to capital M greater equal to 2 small m. Okay, the maximum value of the maximum value of the maximum value of the momentum maximum value of the momentum that any one of that any any one of the lighter items any one of the lighter particle, any one of the lighter particles can have in a direction perpendicular to the z direction, perpendicular to the z direction is. Okay, options are, option A is 1 by 2 c root m square, capital M square, minus 4m square, that is small m. Okay, and option B is 1 upon 2 c root m square, capital M square, minus 2m square, and option C is c root capital M square minus 4m square, that is small m square. Okay, and option D is 1 by 2 mc. Okay, 1 by 2 mc, where c is velocity of light. Okay, so this is the question, guys. Okay, the question is, a heavy particle of rest mass m, okay, while moving along z direction, decays into two light identical particles. Okay, decays into two identical light particles with rest mass m. Okay, where m is greater than 2m. Okay, capital M is greater than 2m. The maximum value of the momentum that any one of lighter particle can have. Okay, the maximum value of the momentum that any one of the lighter particles can have, that we need to find out in the direction perpendicular to z direction. Okay, so that's what we need to find out. Okay, so heavy particle of rest mass is given. It means this particle's velocity is relativistic velocity. Okay, so I'm going to solve it now. So yesterday when I was solving this question, and there was audio issue, and after that my voice was not audible. Okay, so that's why I'm solving this question again. Okay, well, so I'll start. So okay, so here, guys, this is heavy particle mass m. Okay, heavy particle of mass m. Okay, which is moving along z direction. Okay, and p is its momentum, guys. Okay, so very simple question. We are going to use conservation of momentum and conservation of energy, and we'll get the required answer. Okay, so this is the heavy particle. Okay, so there are so it decays into two particles. Okay, suppose this is the particle and this is the particle. Okay, and so its momentum along z direction is p2. Okay, and its momentum along z direction is p2. Okay, and its momentum along the direction perpendicular to z, right, this direction, is suppose p1. Okay, and similarly for this also p1. Okay, so question is this one: a heavy particle of rest mass m while moving along z direction decays into two identical light particles. Okay, okay, guys. Okay, so light particles with rest mass m, their rest mass is m, which is given. Okay, and the maximum value of the momentum we need to find out, the maximum value of the momentum that of any one of the lighter particles. Okay, so we need to find out maximum value of momentum of any one of the particle. Okay, lighter particles can have in the direction perpendicular to z direction. Okay, perpendicular to z direction. So this is p1, this is p1, guys. Okay, so this is the case, guys. Now what we are going to do is we are going to use, so this is the momentum of this particle. Okay, let's suppose p is the momentum of this particle, particle, heavy particle, and p1 p2 are the momentum of this these two light particles whose mass, their masses are m. Okay, this particle breaks into these two particles, or decays into these two particles. Okay, okay, so now we'll use momentum of conservation along that direction. Okay, so now momentum of mass m. Okay, so momentum of mass m. I hope guys I'm audible now. Okay, let me just check whether I'm audible or not. This is important, guys. Particles. Okay, decays into two items. Yes, I'm audible, so I'm going to proceed. Okay, well, so the momentum of mass m, I'm talking about capital M. Okay, capital M, that is going to be P equal to this P, right? P2 plus P2 along z direction. This is P2 and this is P2, right? Okay, along z direction. So P plus P2, P equal to P2 plus P2, or from here we can get value of P2 equal to P by 2, right? Because P2, P2, 2P2, right? And P2 equal to P upon 2. Okay, so this is the value of P2 we have got. Say this equation is 1. Okay, next is, guys, next the momentum of mass. Now momentum of mass small m. Okay, momentum of mass small m. Okay, this is a momentum for capital M. Okay, mass small m, it is going to be this one. No, before that I'll get this one. Okay, the energy. So we have got the momentum for this, right? Now we'll get the energy. So we know the relativistic energy, right? So energy of mass m. Okay, energy of mass capital M. Okay, so we know the formula, right, for relativistic case, that is E square equal to P square C square plus M naught square C to the power 4. So here rest mass is M for this capital. So this is M. Okay, this one. So this is the E square for the heavy particle. Okay, energy. Now momentum of mass M, that is small m. Okay, momentum of a mass m, small m. This is small m, guys. Small m. Okay, so that we'll find out, and this is going to be momentum of, this is going to be this one, E1 square equal to, we are talking momentum of mass m, that is momentum of mass m is going to be, see here, look, this is P1. Okay, there are two momentum of mass m, right? One is along z direction, one is the perpendicular to z direction. Okay, P1 and P2. Okay, so we have to get the resultant momentum, right? So resultant momentum is, these are in perpendicular direction, right? So we know that by formula the momentum of mass m is going to be that we can denote it by P1. Okay, So that is going to be, just we'll write momentum as this is going to be P1 square plus root P1 square plus P2 square, right? We know how to get a resultant of the vector, right? Because these are in perpendicular direction. That's why the momentum of mass m is going to be directly this one, root P1 square plus P2 square, right? This is very simple concept. Okay, now now we'll find the now from equation 1 we'll put the value of P2. Okay, so from equation 1 this is, so P2 value is P by 2, so we'll put here. So this is going to be P1 square plus P2 square upon 2 square is 4. So this is the momentum of mass m, means lighter particle. Okay, this is the momentum. Now we'll find similarly the energy of light particle, energy of mass m. We can see mass m, this is light particle whose mass is small m. Okay, so that we can find out, we can denote energy of light particle by E1. Okay, so E1 square is going to be E1 square is going to be that this one P1 square, right? So that P dash square, this is the P, right, for this for light particle. So the square is if it is a square, so it is going to be P1 square plus P2 square by 4, right? The root will because it's a square, right? So root will get removed. Okay, so plus m naught square c to the power 4 for this lighter particle. The rest mass is small m c to the power 4. Okay, so now now we'll use energy conservation law. Here we have used that momentum conservation law. Okay, momentum conservation law, MC. Okay, momentum conservation law. That's why P is equal to P2 plus P2, right? Momentum, conservation of momentum. Okay, or we can say CM, conservation of momentum. Okay, so here we will use conservation of energy. So conservation of energy means energy is conserved, right? So this E square is going to be equal to, because there are two particles, right? It means E1 square plus E1 square, right? So 2E1 square, right? This is the conservation of energy, right? Means the energy of this particle is energy of this particle plus energy of this particle, and these particles are identical particle and having same mass, right? So that's why this and their energy is same, right? So that's why E1 square plus E1 square, right? This is 2E1 square, right? I hope you have understood it. Now now what we'll do from here, we can get value of E1. So this implies, I'll write in next page, this implies E1 square equal to, sorry, this is not E1 square, guys. This is we are using conservation of energy, right? So this is E equal to 2E1. Okay, E equal to 2E1, and that is from here, that is going to be E1 equal to E2 by 2. Okay, E1 equal to E2 by 2. Simple mathematics. Now we can square squaring both sides. Okay, so this is going to be E1 square equal to E square upon 4. Okay, well, so E square upon 4, okay. So now we can put the value of E1 square and E2 square. E1 square value is this, E2 square value is this. This is equation 2. Okay, this is equation 2 and this is equation 3. Okay, so we'll put the value of E1 square, E2 square, right? E1 square and E. So this is going to be E1 square value is P1 square, this one, P1 square plus P2 square, this is C square, guys, okay? P1 square plus P square we have made mistake here, yeah. This is this one. P2 is P by 2, right? So this is going to be, we have put the value, okay? So this is P square by 4. P square by 4, okay? So this value is going to be P square by 4 C square plus small m C to the power 4. This is going to be equal to P square C square, okay? P square C square plus capital M square C to the power 4, okay? This one. So now what we are going to do is we will solve it. So this is going to be okay. So from here this E1 is 4, right? Because E1 is square, right? So we can write by 4, okay? E1 square by 4. So now we'll solve it. So this is going to be 4 C1 C square will get cancelled, okay? So this is on both sides. So this is going to be 4 P1 square plus P square C square, 4 will get cancelled. P square, just a P square, guys, not C square. P square C square got cancelled, okay? Because C square in both sides, okay? So plus small m, this is m square, this is 4. So we have multiplied, right? So this is going to be 4 m square C to the power C square, right? So this is going to be C is cancelled, right? So P square plus m square C to the power 4. This is capital M, right? Okay? P square will get cancelled, okay? So from here this 4 P1 square. So this is going to be P1 square is going to be, or 4 P1 square is going to be m square C to the power 4, this is capital M, minus 4 small m square C to the power C square, okay? C square. So from here the value of P1 is going to be, P1 square is going to be 2 will go there, right? So this is going to be C by 4, C square by 4 minus, we take the C square common, okay? So this is C square, guys, because C square get cancelled, okay? C square is cancelled, so C square. So so this is m square minus 4m square, capital M square minus 4m square, okay? So from here value of P1 is going to be C by 2 root C by 2 root m square minus 4m small m square, right? So this is the answer, guys, okay? So this is the the momentum, the maximum momentum one of the lighter particle have in the direction perpendicular to the z direction, okay? Well, well, guys, so this is a very good question. Now I have solved it, okay? Okay, guys. So which option is matching? Let me check. So option A is matching, guys. Option A, okay? C by 2 root m square minus 4m. This one, okay? C by 2 root m square minus 4m square, okay? Well, guys, so this question is done. Now next question. Next question is this is also this is also very good question, guys. Okay, so question is question is a frictionless horizontal a frictionless a frictionless a frictionless a frictionless horizontal a frictionless horizontal frictionless horizontal circular table is spinning is spinning with uniform angular velocity with uniform angular velocity omega about the vertical axis about the vertical axis through its center if a ball of radius a if a ball of radius a is placed on it at a distance r from the center distance r from the center of the table its linear velocity will be okay, and options are minus r omega r cap plus a omega theta cap. B is r omega r cap plus a omega theta cap, and option C is a omega r cap plus r omega theta cap, and option D is 0. Okay, so this is the question, guys. I'll read it for you. A frictionless horizontal circular plane. Okay, so there is a frictionless horizontal circular plane, a circular table, okay, is spinning with uniform angular velocity omega, okay, about the vertical axis through its center. Okay, so about the axis which is passing through its center, okay, and a ball of radius a is placed on it. Okay, we have put the ball of radius a on it at a distance r from its center. Okay, center of the table. Its a linear velocity will be, we need to find out linear velocity. Okay, so I'll solve it. So like this. This is a circular table. Okay, this is the axis, vertical axis passing through its center, and about this circular table is spinning. Okay, and this is spinning. Okay, and we have put a ball here whose radius is a, and its ball's distance from its center is r. Okay, now because it is spinning and the table is frictionless, and we need to find the linear velocity of that. What will be the velocity of the ball? Okay, so this is a conceptual question. Okay, so I'll solve it now. Since table is frictionless. Okay, since table is frictionless, then okay, table is frictionless. Okay, then there is not any tangential force, okay, so ball will have zero speed. So ball will have zero speed. Okay, so because the table is frictionless. Okay, because there is no friction, okay, in the table, that is frictionless, it means the tangential force which will work on the ball will be zero, right? There wouldn't be any tangential force because it's a frictionless surface, right? Or frictionless table is frictionless, right? So there is no tangential force. Because there is no tangential force, means that ball is not going to move, right? The ball is not going. So then this means ball doesn't have any linear velocity. That speed of ball is going to be zero. Okay, so very important concept, guys. You need to note down. Okay, since table is frictionless, okay, if there is a table which is if surface is frictionless, right, and it's a spinning, right, if surface is frictionless and spinning, it means there, if we put any object on the surface, right, then the tangential force acting on that object is going to be zero. Means there is no tangential force which will act on the object because the surface is frictionless. Okay, and that's why the ball will have the linear velocity of ball will be zero, or speed will be zero. Okay, so which option is matching, guys? Option D. Okay, so this is the answer, guys. I hope, guys, you have understood it. Okay, next question, guys. Next question is this is also a good question. This question is from electronics and very simple question, guys. Okay, an inductor, question third. Okay, an inductor a capacitor, an inductor, a capacitor, and a resistor, R. Okay, inductor L, inductor L. Okay, inductor L, and capacitor C. Okay, inductor L, capacitor C, whose capacitance is C, inductor whose inductance is L, and the resistor whose resistance is R. Okay, are connected in series are connected in series to an AC source okay, to an AC source. V equal to V naught sine omega t, okay. The voltage is given, V equal to V naught sine omega t. If the net current is found, if the net current is found, net current is found to depend only on R, means resistor, okay, only on resistance, okay, then options are in to find out A equal to that option A is C equal to 0, option B is L equal to 0, option C is omega equal to 1 upon root LC, and option D is omega equal to root 1 upon LC minus R square upon 4L square. Okay, so this is the question, guys. Very simple. So an inductor L, capacitor and resistor are connected in series, okay, to AC source, and voltage is given, and if net current is found to depend only on R, okay, then we need to find what will be the option, correct option, okay. Okay, and solve it. So this is the case, guys. This is inductor, okay, this is capacitor, and this is resistance, okay. They are in series and connected with AC source, AC voltage, right? They are connected to AC source. Voltage is given, that V equal to V naught sine omega t, okay. So this is the AC source, guys, okay. AC source, okay. This is the figure, okay. So we should know, so there's a condition, guys, you should know, if current is depending only on R, okay, in that case, if I depends on R only, that implies XC equal to XL. Means if this is the case, and if current is depending only on R, it means XC, okay, that XC equal to XL, okay. So this is the condition, guys, you should note down, okay. XC equal to XL, and we know the value of XC, right? That implies value of XC is this one, 1 upon omega C, where omega is the frequency, right? And XL means omega, L is inductance, C is capacitance, right? So if current, if this is the case and current depending only on R, it means XC equal to XL, right? Okay. So from here we can get value of from here we can get the value of omega. So this from here this is going to be, this implies omega square is going to be, this implies omega square is going to be 1 upon LC, right? Omega will go there, LC, right? Omega square equal to LC, or then value of omega is going to be 1 upon root LC. So this is the answer, guys. So which option is matching? Option number C is matching, guys. Okay, option C is the correct option. Very simple question, guys, right? So if this is the case and current is only depending on R, right, in that case XC equal to XL. Okay, the impedance of this capacitor is equal to impedance of inductance. Okay, so from there we got the value. Okay, very simple. I hope you have understood it, guys. Next question we are going to solve. Question number 4. Question number 4. Okay. Question number 4. Question 4 is very good question, guys, and very conceptual question. So 3-point charges, and this is from electrodynamics. Okay, 3-point charges Q are placed, 3-point charges Q are placed, 3-point charges Q are placed at the corner of, at the corners of, at the corners of an equilateral triangle. Okay, of an equilateral triangle. Another point charge minus Q is placed minus Q is placed at the centroid of triangle. Okay, at the centroid of the triangle, which is equilateral. Okay, triangle. If the force on each, if the force on each of the charges, if the force on each of the charges Q vanishes, then the ratio Q upon Q is, okay. Options are option A √3, option B 1 upon √3, option C 1 upon 3 √3, and option D 1 upon 3. Okay, So this is the question, guys. Okay, 3-point charges Q are placed at the corners of an equilateral triangle. Okay, another point charge Q is placed at the centroid of the triangle. If the force on the each of the charge Q vanishes, okay, the force on each charge Q is 0, okay, at that point, then the ratio of Q upon Q is, okay, capital Q upon Q is, okay. So this is the question, guys. Very good question. I'll solve it for you. So this is okay. So I'll make an equilateral triangle whose all sides are equal and angle between them is, all angles are 60 degree, right? So this is equilateral triangle, okay, and centroid is here, guide, okay. So there is a property of equilateral triangle that I'll tell you, okay. So this is centroid, guide. This is A, this is D, and this is G, guys, okay. This is G, okay, and charges are placed here. Charge Q is placed here, Q is placed here, and Q is placed here, okay. And at G it's a centroid, okay, and so this is because each angle is 60 degree, right? So this angle is 30, this angle is 30 degree, okay. And yes, and these are the charges. So I'll make a direction as well, okay, then it will be more clear to you. So this is like this, and this is like this, okay. This is A, and here charge minus Q is placed as per the question, okay, and the charge is Q here like this, okay. This is the case, guys, okay. So now we need to find out the ratio of capital Q upon small q, okay. So I'll solve it for you. Well, so this is the direction of force, okay, and charge is Q is here, right? These direction are like this, okay, like this, okay, and in this direction will be like this. This is Q and this is minus Q. So direction is towards negative charge, okay. So this is the case, okay. So here this is the centroid, guys, centroid of the equilateral triangle, and there's a property for centroid of equilateral triangle, guys, and this is AD, this is total distance AD equal to that is DG equal to, DG means this one, DG, this distance is DG equal to 1 upon 3 AD, okay, 1/3 of AD, 1/3 of AD, okay. This is 1/3 of AD, okay. So DG equal to 1/3 of AD, okay. So this is the centroid, guide, and there is a property of centroid. So this total distance, this distance is going to be 1/3 of this total distance, okay. And similarly this one AG is going to be, AG is simple, right? This total distance AD means this distance is going to be 2/3 AD, right? 2/3 AD, right? 2/3 AD. Like simply we can find out this 2/3 AD how. This is this means this one, right? I'll show you here. Right. AG equal to AD minus DG. AD, DG value is 1 upon 3 AD, right? So AG is going to be equal to 2/3 AD. Very simple, right? Okay. this is the value of Ag, guys. Ag. Okay. So now question it is given force on charge is charge Q is 0, right? In every force vanishes at this each charge, right? So since given force on charge Q equal to 0. Okay. So we'll balance the force. Okay. We will balance the force. So here you can see, suppose force on each charge is 0, right? So here this is Q, right? Q, this is Q. So we can see this force is towards this force is towards this, right? And this force is down, right? So it means these forces are balancing it, and the force at QA is going to be 0, right? So so you can see, and we know the force between AG, A, and force between this Q and this Q, this we know, right? That by Coulomb's law, 1 upon 4 is this is 1 upon, or we can say 1 upon 4 pi epsilon 0 Q1 Q2 upon R square, right? This we know. And similarly for this force we'll find. Okay, so how it is balancing, how it is going to be 0, right? So you can see the force is this, right? Force between this is this, right? And here you can see, if we take this perpendicular, right? So you can see distance, right? So like this, if you take like this, okay. So here you can see that this is the force along this is going to be f cos theta, along this f sin theta. Similarly, force along this is going to be f cos theta, and along vertical direction is f sin. This is f cos theta, and this is f sin theta. F sin theta will get cancelled. These are opposite forces, right? So this f cos theta, right? This is f1 cos theta and f2 cos theta are towards this direction, and Q is toward this direction, and these are equal, right? Equal and opposite. That's why force on this is 0, right? I hope you have understood it. So now we'll write force on. So this means the force is 0, means this force is balancing this force, right? That's why force on it is 0, right? So it means by Coulomb's law, K Q square upon A square cos theta or cos 30 plus K Q square upon A square. K is 1 by 4, K equal to 1 upon 4 pi epsilon 0, right? So this is K Q square A square cos 30 is going to be force between this, okay? Force between this is going to be K square Q plus minus Q. This is going to be minus Q, right? This minus Q. So we'll just take the magnitude. Okay, so this is going to be this distance between this. This is AD, AG, right? AG is 1 by 2 by 3 AD. Okay, and the AD value is how much, right? This is perpendicular distance, right? This is A. This is A by 2. So AD is going to be simple. So AD is going to be that we know Pythagoras by Pythagoras theorem, right? This is 90 degrees. So this is AD is going to be A square root A square plus A square by 4, right? So this is going to be root 3 by 2 A, right? Root 3 by 2 A AD by Pythagoras theorem, right? Or now and AD value is this. Now AG is going to be 2 by 3 into root 3 by 2A. So 2 will get cancelled, and this is going to be A by root 3, right? A by root 3. Okay, so AG is A by root 3. Very simple, right? So we'll put here. So this is going to be A by root 3. root 3 whole square, right? Because here we know, guys, the Coulomb law, right? Electric field equal to k square k q1 q2 upon r square, right? Force between two charges, right? This we know, this one, right? So charge q and charge q, force between two charges, okay? This we know. So now, guys, you need to understand this angle, guys, right? Because because here this is the force acting here, right? And it's along this direction, the along this direction the component is going to be, suppose this force is f cos theta, right? F1, okay, f1 cos theta, this is f1 f2 sin theta, f1 sin theta, right? Similarly, for this force along this direction, this force, right, along this direction is f2 cos theta, or along this direction f2 sin theta, f1 cos theta, sorry, f1 sin theta, f2 f1 sin theta and f2 sin theta are going to cancel each other because they are equal and opposite, okay? Because their distance is equal, right? And charges are equal. So this is this going to cancel, only this will f1 cos theta, f2 cos theta, right? To f1 cos theta, f2 cos theta will work along this direction, and they will, okay, work along this direction, right? And they will balance this force, and that's why the force here is going to be 0, okay? So that's why this force plus this force we have taken, only cos component we have taken, okay? Along the vertical component we have taken, okay? So now we'll solve it very simple, okay? So these are simple values, right? So this is going to be this one 2, because same value, right? 2 k1 k2 k u square cos 30 upon a square is going to be equal to k q, we have just taken magnitude, okay? This is my minus sign, so a upon root 3 whole square, okay? So this value is going to be now 2 into this one, k k will get cancelled, okay? Q also will get cancelled, small q. So this is going to be q, okay? Cos theta, cos 30 value is 2 by root 3 by 2 upon a square. 2 will get cancelled, okay? Here q will get cancelled, will be a by 3q 3q by a square, right? A square also will get cancelled, so this is going to be q root 3 equal to 3q, right? So from here we need to find out the ratio of capital Q upon Q. So this is going to be root 3 upon 3. So that is 1 upon root 3. Okay, so this is the answer. Very good question. This is the answer, guys. So which option is matching, guys? We need to find which option is matching, okay? Which option is matching? Okay, so these are, so this we have taken this plus y because sum of these forces is going to be 0, right? Equal forces, so that's why these values are equal. That's why there is no minus sign, okay? We'll write like this: f1 plus f2 equal to 0, right? Or we write f1 equal to minus f2. So this minus will be plus, right? Okay. So this is the answer, guys. Which option is matching? Option B is matching, guys. Okay, option B is the correct option. Option B is the correct option. Okay, 1 by root 3. 1 by root 3. Okay, next question, guys. Next question is, okay, guys, next question we'll do in next class. So I'm going to stop here, And also guys, I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay guys, thank you so much for watching, and bye now.